Hello, this is Letterground.net's video on vectors and scalars. Scalars are quantities which may represent a number, sign, or a unit, such as mass, density, or energy, as you can see over here. Vectors are quantities which require magnitude and direction. Example would be displacement, force, or velocity. An example of a vector would be, say we are moving this far, this way, let's call it 5 units to the right, and then we decide to move 3 units back to the left. We now have a total change of 5 minus 3, which is equal to 2 units. So the displacement for this vector quantity over here was 5 units to the left, minus 3 units, and that will equal 2 units to the right. Here's another explanation of it. Okay, say we were going to, say we were moving 15 meters per second this direction. And then we decide, so 15 meters per second, and then we decide to add another vector to this, which is moving 10 meters per second parallel to it, parallel to this vector. This will give us a vector still moving 5 meters per second that direction, because it has gone 15 meters, it's going 15 meters per second, let's call this, up this way, and then you minus off the 10 meters per second this way. That would be an example of vector quantities. A scalar quantity is any quantity, it doesn't represent direction at all. So, mass, we can call this a 50 kilogram object. There's no direction to 50 kilograms, or, if we're doing energy, there's no direction to 50 joules. Those are just quantities. Now you can multiply them by vectors, and the vector quantities will still be the dominant one, telling you the direction. For example, a scalar quantity would be time. There's no direction to time, so if we take an object moving this way at 50 meters per second, or 5 meters per second, and we multiply it by 5 seconds, since that's a scalar quantity and a vector quantity, we will have moved a total of 25 meters this direction, the same direction as the meters per second quantity. Now, there's a few different ways you could work with vectors. Let's say there's 2 vectors going this direction. They're both the same quantity in the same direction, so I'm going to call them both A. If we add those vectors together, we will get 2A, or in line, that's both of these added together. Now if we have 2 that are going, let's say, this way, and they're both of magnitude A, that'll equal none, because if these are both equal, they just cancel out. If there's, say, a vector like that plus a vector like that, and we'll call this one A and B, we'll add those together, and we'll get something that looks like this. Okay, now to get this C right here, we use what we know from geometry and do A squared plus B squared square root equals C. Since this is technically a right triangle, we can move this A over here, and this would be a right triangle. Now I'm going to wipe this all. In this last case, we're going to take 2 vectors and add them together. We'll take a vector like this at a specific angle, I'm going to call this north, south, obviously east, west. And another one at theta. This will be green theta, obviously. And then we will try to add them up and ask what they equal. Now the way that we solve these problems is we break every vector into their axes, or we want their x and y direction, or since we're using over here, north, south, west, east, west, we're going to break it so this is east for both objects, for both vector quantities. These two vectors right here and here are both going east, and these two are both going north. So what we do is we take, if we have this line over here, when we break it down, since this again makes a right angle, what we will do is we'll call this C, and we will take C sine theta, because sine is sine theta is equal to opposite over hypotenuse, which is equal to hypotenuse sine, which is sine, which is therefore equal to sine times the hypotenuse equal to the opposite, which the opposite in this case would be right here. Now for down here in the east direction, we have C times cosine theta, and down here we have again, I'll call this C, this will be the green C. We have C sine theta and C cosine theta. So what we're going to do with this information is, once we get all these, which we're going to take out, since they're all vector quantities and we're adding these two vectors, we're going to take the vectors and basically add them all up in each direction. So I'm going to leave these two pictures here. So, since we have C sine theta, now remember this is the red one, going in the north direction, we'll add it to C sine theta going in the north direction with both, so both vectors will be equal to, and then I'm going to call this the north vector. And for the east vector, since this is north and east, I will take C cosine theta plus C cosine theta, and that'll equal the vector in the east direction. Now the way I get this new vector, which would be those two added together, is I take north, I just act like these are both two new vectors, I take the north vector squared plus the east vector squared, take the square root of both, and this will equal our new C vector, which is actually what we're looking for. Now I'll have examples on lettergram.net of this, probably a little bit better examples. I was just trying to give a quick explanation so that everyone could understand what vectors were. And if you're taking more of a calculus-based physics class, I'll have a follow-up video which will be vectors with calculus. I hope that this video has helped you, and if you want any downloadable content or have any more questions, feel free to either comment on the video or go to lettergram.net.